Hello everyone, my name is Samson. I'll be going over my presentation 3, my final project report. So just a recap on my project. So the purpose of my project was to analyze the network captured data of the 3 datasets that I have chosen, the KKids 2017, the What 0919, and the KDDID. So the purpose was to distinguish the difference between a attack and normal traffic that can initiate or trigger a preemptive response before an intrusion occurs. So the purpose was to identify characteristics of the data packets within the primary data set. Then I was to use that primary data set and use the 2 supporting data sets to support the information that I found from the primary data set. The scope focuses on analyzing the 3 datasets for key variables that have been used frequently for attack entries. By identifying those key variables, they will create the characteristics needed to allow system administrators to prevent further attacks. So the project statement that was created was the data analytics problem that I am analyzing is how an NID determines what is normal traffic and what is an attack based on captured traffic. So this will consist of 3 large datasets where correlation characters will need to be found for substantial evidence. So bottom line, this project focuses on what happens in the network as packets travel through. This includes forward and backward traffic hitting different nodes at a time from the source to the destination port and from the destination port back to its source. So from the first presentation, I brought this diagram into one of my first visualizations. So the purpose of this project was to identify these areas right here, the attacks, and from the unidentified devices. So to protect the customer who uses their device, such as a computer, laptop, or cell phone, they would send requests or data pings through the internet in the form of packets. These packets would hit the internet, it would hit the router, go to the switch, go to the server, and to the information owner who holds the server. So the purpose of this project is to help system administrators identify these attacks before they even enter the network, or at least find the characteristics that build up to these attacks. So dataset summaries. The KKids 2017 focused primarily on the data packets itself. The secondary dataset, What 0919, focused on the protocols, services, attack types, and duration of the transmission. KDDID analyzed each connector node that the packet passes through. So KKids 2017 was the only dataset with missing variables. These were removed as there were only 1,358. This is spanning across 8 datasets, individual datasets. The rest of the variables were converted to be uniformed across the datasets. The primary dataset, KKids 2017, had 72 variables. The primary variable was the destination port. This dataset consisted of 8 individual datasets. They all had the same variables, but different values. So the work had to be repeated on all 8 datasets. This included running the same R script on 3 variations, which had 3 different distribution rates and different model types as well. So this is a little diagram that I made for the primary data set. So the packet transmission will start with the source and the packet will be sent. So this data set focuses on what happens between the packet that was sent until it reaches the destination port. This would focus such data such as the forwarding packets, the total length, the average bytes or bulk size, the average packet size. The secondary dataset of What 0919 has 38 variables. This dataset has several variables that will connect the 2 separate datasets with variables such as network protocols, computer services, transmission duration, and attack type. So this dataset actually focuses on the data packets that are encapsulated with an attack. So this would focus on the length of time that it took for the packet to deliver, the protocol type that goes through the network that allows it to move on from node to node, the urgency, the priority. The additional dataset, the third dataset, consists of 42 variables. This dataset connects the other two datasets as well with key variables such as protocol types, action flags, and services used. The KDDID dataset focuses on what happens when the source hits different node connectors of the network, such as different servers or different routers. So as you can see, the 1, 2, 3, 4 they represent like servers or nodes. So what happens when your packet goes from the source to a server to another server, and then finally to its destination port. So for this project, I chose the linear regression model and the neural network models. So the linear regression models will allow the project to project the growth rate of the project objectives prediction. Neural network models will consider the variables that contribute the most towards the creation of models' weights against its primary objectives. I have chosen Tableau to create the visualizations for the project. Here are a few examples of what was generated from Tableau. On the left, we have the packets of data produced per day, the average packet size, the protocols used for the duration of the transmission of the data packets, and the protocols used on the connector ports of the KDDIDs. The final report. The applications used were Tableau, a visualization software to help produce the graphs, and RStudio, which help produce the predictive models such as the linear regression and neural network. The key performance indicators or business success factors. There were 4 created for this project. The first objective was met as the project was able to identify attack and normal data. This was accomplished when the attacks were separated from benign and actual attack data. This was essential as it provided a step towards identifying the attacks. This allowed the project to separate from the benign data. By dividing the data, this allowed the project to just focus on attack data. This helped the project progress towards the next project objectives. As this is important, this allowed the project to separate unnecessary data and allowed the project to work with just attack data. The second objective required the days to be compared and the day that had the most activity needed to be identified, which was achieved. This step was reached as the previous objective had been met. This is a critical step. By identifying the day with the most activity, this essentially becomes a data-rich dataset that will be able to answer the next set of objectives. This step, like the previous step before it, is needed to progress to the next objectives. Identifying that the Wednesday dataset allowed the other individual datasets to be utilized as supporting datasets. Rather than pruning through and wasting precious time, it is because of this dataset that the project may have succeeded. The third objective focused on analyzing the data packets within the primary dataset, which was met. This objective was split into 3 mini-objectives. This was due to the dataset having variables that focus on a specific direction. There was a forward-directional data flow that consisted on data that push information in a forward direction. Contrary to that, there was a backward directional data flow that consisted on data that just push information in a backward direction. This was to separate data that pushed from a source towards a destination port and then data that was pushed back to a source from a destination port. This is important to answer as attacks can burst from any direction. The final objective required the datasets to have the services and functions to be determined when used during attacks. This is important as attacks and intrusions need to disguise themselves to enter a network. This was unpredictable, but thanks to the beneficial NID and the information generated from this project, these attacks and intrusions can be predicted. By identifying these disguises, attacks and intrusions can be stopped before fruition. This is the very purpose of this project, and by completing these objectives, the project goal has been met. However, there is still room for improvement, and this project can solve much more further into the future. So, the result for the project was, for the first primary dataset, destination port as the primary variable for the unbiased directional data flow. Out of 72 variables, only 4 were significant during the prediction models and the visualization of Tableau. As you can see, for the 4 directional data flow, there was a total of 10 variables. The backward directional data flow had 5 variables out of the 72 that were outstanding. The other 2 datasets, the WET0919 and the KDDID, out of 38 variables, 5 stood out, and out of 42 variables, the primary 3 were the UDP, private, and security features. So through these models, or through these variables, these primary or key variables are what make up the characteristics of attacks. So when an attack had happened, these variables stood out the most during the creation of those attacks. The results of the Tableau visualizations produce these key variables. From the primary dataset, we have flow duration and flags, which connected to the second dataset for the duration and the flag variables as well. As you can see in the second dataset, it has protocol type and services, which connect to the KDDID, UDP, and private. These were actually renamed as protocol and services as well. So the 3 datasets have all correlating information that provide, I guess, like a unique standpoint. So the datasets actually agree with one another, which help the project reach its objective and primary project goal. Insights. So intrusions and attacks can occur before a network intrusion detection can identify it. This is considered the first stages of executing an attack. So this would include like monitoring routines, knowing the countermeasures, staging the actions, placement of the actions, disguising intrusion attempts leading up to the attacks, and finally execution, when all aspects of the attacks utilizing all the variables that the attack requires to reach its goal. NIDs have captured data that has passed through the network. This data has captured key variables that have spiked in usage when these attacks execute and have been identified by NID. So these variables stand out during the neural network and linear regression models. This requires the use of the particular variables in order for these attacks to occur. When an attack or intrusion occurs, it is documented, and the characteristics of that attack is recorded. The datasets have presented all the attacks and the data that these attacks have used. But what can be learned from these datasets is creating R scripts that extract the variables utilized during these attacks. When looking through the data, the variables are recorded, and the attack that occurred can be studied. My project has captured that data. So by studying the extracted information, it can be used to output a series of variables that can be monitored or used for further studies to prevent such attacks. What this project has captured is key variables. So the 3 categories for the primary data set, which were the destination port, the unbiased directional data flow, the forward directional data flow, and the backward direction data flow. I was able to capture 4 variables out of the 72 for the unbiased directional data flow. I was able to capture 10 variables out of the 72 for forward directional data flow and 5 for backward directional data flow. These 19 variables can be monitored closely. I was able to identify 5 variables from the secondary dataset and 3 variables from the third dataset. By monitoring specific variables that have caused the attacks, they can be identified as key aspects towards a precursor of an attack. These were 3 examples of the models I was able to create or produce out of the R Studio. As you can see, the reason why I have chosen the first allocation of 60% towards training and 40% towards tests, as you can see, the error rate is much lower than the other 2. And then the steps required to create the models were much less for the 60-40 distribution. Allocating 80% would just increase the amount of steps and the error rate would rise. So for all data sets, for the 8 individual data sets within the primary data set, I have applied the 60/40 distribution towards the 8 data sets with the 3 variations. What I mean by 3 variations is that when I created these models, one variation focused on unbiased directional data flow. The second variation would be backwards directional data flow, which, as you can see, all the variables that had a backwards orientation for the data packets were included in just one variation of the models. The third variation would be the forward directional data flow, which focused on all variables that push the packet forward. So the first variation had, I guess, more of a neutral or general characteristics or variables that model the data packet. The second would be backwards. The third would be a forward. Now I want to point out that this had occurred for all 8 data sets. So I would include like a Monday, Tuesday, Wednesday, Thursday, and Friday. Each day was divided into 3 variations. So essentially, I would have to run the same R script at least 28 times. For the primary data set, KKIDS 2017, it was discovered that these variables have been identified as the key components to a majority of the attacks. The primary data set was divided into 3 types of models: destination, forward, and backward. From the destination types model, it was found that flow duration, down-up ratio, average packet size, and max length were the leading variables that contributed towards the attacks. Forward type models, it was found that these variables contributed the most: forward IAT total, forward IAT mean, forward packet length mean, initial bytes forward, total length of forward packets, total forward packets, down-up ratio, average packet size, flow duration, and forward packet length max. For the backward type models, it was found that these variables contributed the most: flow duration, total backwards packets, down-up ratio, backward IAT total, and backward length mean. The secondary dataset, 10919, it was discovered that these variables have been identified for contributing the most towards the creation of the models. This indicates that these variables have been identified as key components during attacks and intrusions. These variables are duration, protocol type, service flag, and count. The variables identified in these datasets correlate to other datasets, such as KKIDS 2017 has identified that flow duration as a variable used in key attacks, just as what O1919 has identified as duration. KDDID has identified UDP or protocols, just as what O1919 has identified protocol types. What O919 services has identified what KDD has also identified as services as a key variable. The third dataset, KDDID, it was discovered that these variables have been identified for contributing the most towards the creation of the models. This indicates that these variables have been identified as key components during attacks and intrusions. UDP, private, and security features. UDP is named differently, but the values within the variable are similar values as used in what O1919 protocol type. These two datasets have identified a similar value that is a correlating value that ties both datasets together. The protocol ICMP was identified as a protocol highly used during the attacks and intrusions. The Tableau visualizations have identified correlating values that connect the 3 datasets together. The Tableau correlation between what O919 and KDD displays the protocols used during the attacks. It is clear that the protocol ICMP was used the most and is confirmed with 2 different datasets. The visualizations created from KDDID were also needed to interpret the neural network graphs and output generated from RStudio. The variables that were used were the connection variables, X. However, with the use of Tableau, it can be interpreted with services, flags, protocols, and attack types. So as you can see, the findings have created a chain of events that have connected from Tableau RStudio. The chain of events that had started from identifying the day that had the most activity. This first graph right here points out that Wednesday had the most network activity, which is suspicious as the rest of the data sets have like a bar graph in between. The second graph was generated from the primary dataset. This graph displays the flag count. This particular flag count is raised when data packets move from one connector point to another. Think of it as a receipt of an exchange. When something happens, a flag is raised. As you can see, the highest point that the 8 datasets had peaked was on a Wednesday. Again, this supported the theory that Wednesday was the most active day that had received the most attacks. Moving on, the third graph displays that the data packets moving out of the network. Wednesday again displays the most activity. This is a total count of data being sent from the destination port back to its source. The fourth graph generated was from the secondary dataset. This is to provide an outside source of information that confirms the type of attacks that occur the most. This tells us that DOS, or denial of service attacks, occur the most over normal data traffic. The fifth graph was generated again from the primary dataset. Benign is normal data traffic, but as you can see, the DOS is the second most identified type of traffic captured. The story moves on from a primary dataset to the secondary dataset. What 0919 proves that in these two graphs, the protocol types were consistent with that of the third dataset, which was ICMP. We end this trail of data by connecting the data found from the visualizations to the RStudio graphs. By running R scripts that have the best data distribution of 60% training and 40% testing, we have come up with the outputs that tell us which variables make up the models and have contributed the most towards these attacks. After reading through 28 different graphs, I have highlighted the variables with the highest contributions that have concluded with the information presented. Lessons learned. This project had the intent of identifying characteristics that is associated with attacks. As the project scope states, it was intended for the analyst to focus on what an NID detects. Attacks occur and begin its build-up towards an actual attack, so these actions can start small and build up towards an attack. The NID will be alerted once a certain number of characteristics have been identified. It was the intent of this project to identify those small buildups or accumulate the combination of variables in order to identify an attack before it occurs. A majority of the project had focused on the primary dataset. This dataset had contained 8 individual datasets. It was found that this dataset alone could have sufficed the project's goal. However, to provide a variety of inputs, 2 additional datasets were included with the analysis, 10919 and KDDID. If the study had focused only on the primary dataset, it could have extracted more information from the 8 datasets. The data could have been more detailed and honed on each day. It is recommended that analysis be done on the primary dataset alone. Including two additional datasets has overwhelmed the data output and may have veered away from a higher importance that could have been achieved. The 8 datasets have enough information that have solved deeper issues within the network intrusion detection. The 8 individual datasets contain 72 variables, but not all were used for the creation of the models. There are more than enough variables to solve more issues. However, combinations from KKKids used for this project focus solely on the packets. To further advance through this project, it is recommended that the results be compared against the dataset that was created after 2017. The KKids 2018 dataset was created with a similar purpose, but with 80 variables. The variables that were identified from KKids 2017 can be compared with 2018. The results from the KKids 2018 would either solidify the insights accrued or differ from KKids 2017. If the data differs, this will indicate that the attacks have evolved and have taken a different route to implement attacks, or the KKids 2017 data was unsound. The dataset would have to be compared either as a whole dataset or each day dataset compared against the same day. For example, KKids 2017 Monday against KKids 2018 Monday. The 2 additional datasets that were used to support the primary dataset were indeed useful. The 2 datasets were able to provide correlating data that tied the 3 datasets together. By doing so, this ensured that the data output from the primary dataset was assured information. This endorsed the information and allowed the data to be true and globally accepted. The two additional datasets were not necessary but did not affect the results negatively. The primary dataset could have successfully worked as a standalone dataset and provided the same results. For future analysis, it is best to work with the first 2 datasets of KKIS 2017 and determine the best data allocation before proceeding with the rest. This will avoid having to run the models multiple times. Each day presents a different type of attack, so multiple theories can be created for future analysis. In this project, it was found that Wednesday had the most activity. However, this could be further exploited if every other day was analyzed to disregard activity and focus solely on identified characteristics. Future analysis can further explain why each variables were selected per attack. Each day had a different purpose of attack, but these variables could have been selected due to vulnerabilities embedded into the service or protocol. Again, to recap, here's the original variables that were included in the datasets. A total of 152 variables across a total of 10 datasets. The primary dataset had data that needed to be evaluated at least 28 times. And by evaluating what was necessary to create the attacks, we have concluded with these 19 variables. These 19 variables are the key characteristics that this project was created to search for. As a system administrator myself, these are the key aspects of a network that I could monitor to ensure that my network and information is safe. Here are the references that I have to use for my project. Thank you and take care. If you have any questions, please let me know by email. Good luck everyone, and have a great day.